Let's start by talking about ratios. Ratios are basically a fraction. In fact, they could be written as a fraction, like a over b. Or you could say the ratio a to b with a colon. Or you could say a to b with the word 2. Or it could be written, it's basically still a fraction, but like this. It's just a comparison of two numbers. So for example, we're going to be comparing the length and width and diagonal and perimeter and area. So first, the length to the width. The length is 24. The width is 10. So we can say 24 to 10. Width to length would just be the reverse way. The width is 10 to 24. We could do any of these methods. I'm just doing one of each. The length of the diagonal to the perimeter. So we need to find out how long the diagonal is. This is a rectangle, so that means it's a right angle. And this is, looking at these numbers, I see 10, 24. So I recognize that as a Pythagorean triple. It's a 5, 12, 13, but everything's doubled, so the diagonal is going to be 26. You could just do Pythagorean theorem, 10 squared plus 24 squared equals diagonal squared. So the length of the diagonal is 26. And compare that to the perimeter. Perimeter is going to be 24 plus 24 plus 10 plus 10. So we have 48 plus 20 is 68. And last, we're going to compare perimeter to area. Perimeter is 68, we just found. The area, base times height, 24 times 10, 240. Now the only thing that we need to do for each of these is they all need to be reduced. So 24 to 10 would reduce to 5 to 12, or 12 to 5. The next one, 10 to 24, I was thinking ahead, reduces to 5 to 12. Next, 26 to 68. That will reduce, both even, let's divide by 2. 13 to 34. 13's prime, so that won't go any further. 68 to 100, or to 240 will reduce. Divide both by 2, you get 34 to 120. They're still both even, so that'll reduce. Divide by 2, you get 17 over 60. 17 is a prime number, so that is reduced. Now we can talk about proportions. Proportions are just ratio equals ratio, or fraction equals fraction. So you have A over B equals C over D. We have a ratio equals a ratio. With proportions, you can cross multiply, meaning we can get A times D, and that will equal B times C. You multiply across the equal sign. You can also exchange the extremes or the means. The extremes are the downward diagonal, so you could exchange the extremes and exchange D into A. You can exchange the means, which are B and C in this case. So then you would get A over C and B over D. Or you could invert each ratio. That means flip each ratio. So you could get B over A equals C over D over C. So to determine if something is a proportion, it just has to be true. So we could check any of these things to see if it would make it be true. Or simpler to figure out. I think the easiest is just to cross multiply and see if the products are equal. But sometimes it can be easier. So since these are fractions, rather than multiplying 21 times 45 and 27 times 35, those are pretty large numbers. When you multiply them together, you could also simplify the fractions. So 21 and 35 could be divided by 7. You get 3 over 5. Also 27 over 45, those can be divided by 9, and you would get 3 over 5. Since that's the exact same, yes, it's a proportion. Now looking at B, if we were to exchange the means, we would get 21 over 35 and 27 over 45, which is the same. As we just showed, they're equal. So yes, that is a proportion. And example C here, if we exchange the extremes, we would get 21 over 35 and 27 over 45, same as what we had, so yes, they're proportions as well. If there's a variable in the proportion, you just solve by cross multiplying and then solving that equation. So we get 14 times y equals 42 times 17. That's actually pretty difficult to multiply unless you want to pull out a calculator or do the multiplication by hand, which could take a little while. So there's actually a shortcut. If you remember that you can exchange, we can exchange the means. So if you do that, you'd have 14 over 42 and 17 over y. 14 over 42 can be reduced. They can both be divided by 7. So we would get 2, and 6 times 7 is 42. So we get 2 and 6, which can actually go one step further and make 1 and 3. So when we multiply, we get 1 times y and 3 times 17. 3 times 17 is 51, so y equals 51. For our next example, we would have 42 times x and 7 times 31. Not really a big fan of doing 7 times 31, so we can look for a little bit of a shortcut. Again, we can exchange the means. So that would become x over 31 equals 7 over 42. 7 will go into both of those, so we get 1 over 6. So when we cross multiply, we get 6x equals 31. Divide both sides by 6. And I would just leave it as the fraction 31 over 6. Next, let's look at another example. This one talks about snapshots or pictures. You take an original 3.5 by 5 inch photo and you want to enlarge it so that the width is 18 inches. And you don't want to lose any of the photo. You don't want to crop it. So we're going to set up a proportion, length to length and width to width. So you do 3.5 to x equals 5 to 18. So when we cross multiply, we get 5x equals 63. Divide both sides by 5. You get 12, because 5 times 12 is 60, with 3 left over, so it's 12 and 3/5, or 12.6 inches. And that's what it was asking for. The height of the larger photo would be 12.6 inches. Proportions lead us to one more concept, which is the geometric mean. Before we talk about that, let's refresh and remember what the arithmetic mean is. And that's just, you normally just learn it as the mean, which is the average. So the arithmetic mean between two numbers, you add the two numbers and divide by 2. For the geometric mean, there's 2 ways to write it out, basically. One is as a proportion, but in the proportion, the bottom of the first and the top of the second fraction are the same. And then you solve for b. You say b is the geometric mean of a and c. Here we would say that whatever we set this equal to, x is the arithmetic mean of a and b. But when you solve this, we get b times b equals a times c. B squared equals a times c. And going one step further, b is the square root of a times c. So for the arithmetic mean, you add the two numbers, divide by 2. For geometric mean, you multiply the two numbers and take the square root. So to find the geometric mean of 3 and 27, we're going to multiply those two numbers, 3 times 27, and then take the square root. 3 times 27 is 81. Take the square root. You get the geometric mean is 9.